to this beginner tutorial into game development in Unreal Engine 4. Today we will be looking at splines, so let's get into it. Okay, so splines. A little bit about splines then. Splines are a sequence of nodes that together form a connection. A probably very common example, you can see it in games, are things like ropes or pipes or roads. They would then be made up of different points along a line, and then these meshes or more advanced structures would use these different points along the spline to make sure that it follows the connection and bends and travels along the whole line, making sure that it all stays connected together. It will become more clear once we start working with it. We will be doing a couple examples about it today to make sure that you get a good understanding about how they work and how they're built, and also hopefully give you an understanding about how you could use it for other things than these examples. To start off, one way you can use a spline is as a sort of a pathway where something can follow. This was one of the first ways I made a spline when I started off learning about Unreal Engine. I made a small little bit of logic and created a platform which would follow a spline. So if we do something similar like that, we start off by right-clicking and creating a blueprint class of the type actor. We can call this our BP underscore moving platform, for example. And we open this up. Now, what we need to have are a couple of things. First of all, like most of the time, we want to have a static mesh because we need to have some kind of physical representation. We can call this our platform mesh also, so we know that what it is. And for simplicity's sake, we can just use a cube, and we can scale it down a little bit on the z-axis, so it's a little bit flatter, like so. So this will represent and be our platform. Now the spline part. We go and add a component and type in spline. You can see we have a utility spline here. We add that and we'll let it have its name as spline. Now you might notice that something happened here. You got a line being drawn out here and a little dot. This is the base for a spline, because like I was talking about earlier, how you have a connection that can be fairly long, the very minimal of a spline would be the distance between two different points. So it might be difficult to see, but there is one starting point in the middle of this object here, and this is actually the second point, and then the line goes between them. Now this is just the starting point. The lines themselves can be much more advanced, and they're fairly easy to build upon. So let's do that. We compile, save, and go back into the map. So starting off, if we were to just drag our object into the world and place it a little bit up in the air, you can see we still have the line here with the points out. And if we were to click these points, we can see that we get an additional line out here. This is the tangent, so if we were to have more lines, you can use these to shape how the connection is going to look. It is very easy. You can just grab any point like this and you can move them around, and you can see that the line is going to be altering between these two points that you have. To add a new point, it's very easy. It's the same thing that we used earlier in the tutorial series when we learned about how we can quickly copy objects in the world. One of the ways we can do that is by holding down Alt and then either rotating, dragging, or translating. So by holding down Alt and moving here, for example, another point will immediately be created from the point that we copied. And then these points can also be dragged around and moved And you can see that as we are moving these points, actually it doesn't update immediately, but if we were to go back to here, you can see that the gizmo is pointing in a certain direction. If we move this point over here and release, you can see that the gizmo updates. This represents the actual rotation of the this spline at this point. So since we are creating a moving platform and this spline is supposed to be the pathway from which the platform will be moving along the spline, this is representing what kind of rotation it would have at that point. So you can see at this point it would have this rotation, at this point it would have that rotation, and we will be making transitions between these, not only as rotations but also as translations when we're moving. So this is where you can actually go crazy and you can make this however simple or complicated as you want, and you can have as much fun with it as you like as well, and just play around and do whatever kind of a path you want for this platform to have, right? But yeah, now we have a platform, but we don't have any actual logic to move along this path. So let's do that now. Also, one thing to note here is what we created here now is an instance of the class moving platform. So this will be the path that this particular platform has. It will not affect any other. So if we were to bring a new object in here, you can see that it has its own pathing here. So that means that you can create individual paths per platform that you put into the world. Okay then, moving into the actual logic of getting this platform to move. If we go into the platform and we go to our event graph, the first way we're going to demonstrate this spline is by doing a simple timeline. So we can say on our begin play that we should be playing a timeline which should be handling the actual translation and rotation of the object, our platform then, as it moves along its path. And it's super easy for us to change this afterwards, because if we want to have a different platform, we just replace the mesh, right, and it will be fine. I see that we've created the spline under the platform mesh here. We can move it so it's attached to the normal scene route here. Anyway, so we'll just start off with a timeline. So we have a timeline. We'll call this progress along path. Now if we do it this way, what we have to do is we have to set a certain length. So let's say we have 4 seconds. So this is the duration it will take from start to end, which means that if we were to have a very long path, if we were to create 2 instances of this object with this particular solution, and one of the platforms moved a short distance and one of the platforms moved a really long distance, then it would all move that whole distance in 4 seconds. Just so that you are aware. So this might not be ideal for that particular scenario when you have like reusing the class for different lengths like that. But we'll start off with this, and we'll call this distance along track. So this will be our distance. So we'll add 2 keyframes just like we have done many times before. We'll create at time 0 we want to be at value 0, meaning the starting location, and at time 4, which is our end in this particular case, we want to have 1, meaning 100%. And you can click these buttons so you can see the whole graph. So this means that in 4 seconds we will travel our whole path, right? So we go back to our path, our event graph. You can see our timeline would be playing from whatever point it has now. We don't have play from start currently, but this will be fine for now. And we want to have it update our location every time the timeline is updating. The thing that we want to update now is our platform mesh. So if we were to get that here, we want to set its location. We can set its relative location, and we want to activate that upon our updates. Now our spline is what we're gonna be needing to know where we are, and you can reach it either from the components up here or from the components down here among variables. And you just drag it in, and you can get a distance. Let's see, let's try get location. Location at distance along spline. No, that's not what we want. Actually, that would work if we do this. Get spline length. So the spline length in this case would be the total distance from the start to the end in units. So since this track is going from 0 to 1, meaning 0% to 100%, we can multiply these float by float, like so. And then we put that into the distance here, which means that we would have the specific distance that represents how long we should be along the spline here. And we can just put this into our relative position. Like so. Let's try it out and see how it works. So now you see the platform is moving around, and it's moving along the path that we expected it to move. But you might have noticed it's just moving. We might want to have it actually rotate along its blind path's rotation, right? So we might want to have it sort of banking to the left when it gets to the point over here, and then here, and so on, right? So if that is something that we want, again, this is optional. You might not be wanting this particular behavior, but if you wanted that, you can take the mesh and add a, or set a rotation. Set relative rotation. Again, you might have noticed there that set rotation. You actually have a node that says relative location and rotation at that, and by doing that you could actually set these two things at the same time if you wanted to do that. We're keeping it separated for now. Anyway, just like we did here where we got our location, we can also get our rotation from this spline component. Long spline should probably be the right one, right? Since it's the same one as this one. And we have a distance needed here as well, so we'll use the same distance as this one. And then you can add rotation in here, and then it should be playing fine. So now you can see it's actually banking around the spline. Something that might be a problem or not, depending on what you're actually after. You can see that it's rotating in all angles. Some of them might be more problematic than others, that for example it's banking down here. This is related to these rotations, of course. So if we were to break these, split the struct here, you see we have a rotation for X, we have a rotation for Y, we have a rotation for Z, and when we put this rotator in here, we get all three of those. And that means that if we go here and check on this object, and we change to the rotation scheme of it, you can see the blue, which is representing the Z-axis here down to the left in the gizmo, is around the Z-axis. So if you want to keep that rotation, you would make sure to send that property in here. So like the Z, for example. That will make it rotate around the axis of Z, which goes up and down. If you wanted to keep the other rotations like Y, which is the green one, then it would be able to do the banking backwards and forwards that we saw, or it's called pitch, I believe, normally. And then you also have the red, which is the X, which would be the banking sideways. And depending on which ones of these that you want, you can put all or some of these into it. If we were to just keep the Z here, for example, it would just be spinning around the Z axis, and you see it looks like that. And then it will not do any banking to the left or right, and it will not do any pitching downwards or upwards. That's how those things work. Now, you might want to have some functionality like maybe it going backwards and forwards, for example. There are, of course, many ways to handle this. Some are better, some are worse. One way to do it would be if we go into our spline, for example, and we were to add another key. We can set this at time 2, which is in the middle, and then value 1 for that one. And then we go back to our last key and change it from value 1 to value 0. And you see that we're actually having a spike that goes up to the top and then go down. That means that we will start at the start and we will go towards the end, and we'll reach our end at 2 seconds now instead of 4 seconds. And then since it's going downward, that means we will be moving towards our start location again. So if we compile and save and check this out, you can see that it's first of all moving much quicker now because it's using the 2 seconds instead of the 4 seconds as a total, but you can see that it's moving the whole way back and forth. Now you might want to have something like have this repeating over and over again. To do that you can press in loop if you have this type of solution, and it would go back and forth, and it would continue looping since it's a timeline now between those two different states. There are different ways of solving this, of course. You can have it going, for example, from 0 to 1, and like, let's demonstrate that. So we can actually remove this key if I can press it. Left click and delete key, and then we mark this key and we put it to 1 again. Now this isn't going to be very good that we have 0 to 1 and looping, because this is a bad solution, of course, because you can see it will just be going from the start to the end, and then it will be teleporting to the start. That isn't very good. So we'll remove the loop for now, and we go back to the event graph. And what you could have now, for example, is that once it has finished, because this one will now go from start to finish, and then you may want to go from finish to start. So then you might want to do something like a new event and say let's see, what's a good name for this? Travel another time, and then we'll have an input saying forward question mark. So this parameter would decide if we're going to go forward or if we're going to go backward. So we add an if here and just plug in our boolean in there. And if we're wanting to go forward, then we go into the play, and if we want to go backward, we're going into the reverse, right? So whenever we have finished one of these, then we can call upon this event, travel another time, like so, but we want to give our boolean here to say what our path is. So we'll make a boolean saying forward, and we'll have this as default yes, because we're traveling forward to begin with. And after we have finished, we want to set this boolean so that we can put it in over here. But we want to make sure that our boolean is first of all changed. So it was the opposite of what it was to begin with, like so. So this means that, well, we can demonstrate it first, then we can go through it. So now you can see it's moving forward, and then it's getting to the end, and then it's going backward, and then it's ending up at the start again, and then it's going forward again. So to describe what we have been doing here now then. We have at the start, when the blueprint is created at the very beginning, we say you want to go along the path, and it keeps updating and setting its translation, its rotation for the mesh that's based upon how long it is along the spline. Then once it has completed doing this timeline, what it does is it calls this part of the code which says if I was moving forward, I should be set to moving forward false now. Then we say travel another time, and travel another time goes in here, and it says, well, depending on what my boolean is set for, if I want to move forward, then I want to start from the start of the timeline, otherwise I want to go from backwards in the timeline. And then it will again go through the updates, doing the same thing, and once it has finished it, regardless of which direction it is going, call finished, and it will then reverse whatever direction it was going before. It might look a little messy, but I hope that the explanation makes it clear anyway. But feel free to play around with this. It's a cool system to use, and it can be used for a lot of stuff. In the meantime, we will move on to another example. So we'll just save this for now. Like I spoke in the start, one of the typical ways you can use splines is for something like pipes or roads or something like that. And it's quite simple. We can make a similar class to what we just made. Let's call it actually. Let's make a blueprint class and make it of actor. Call it bp underscore. Call it pipe because this will be the easiest to explain. And we open that one up. And now we will do something similar to what we did before. First off, we add a spline, like before, to our components. And we keep the name spline. Now, we want to go to the construction script because the construction script will allow us to have since we're building a pipe now, we want to have it in the construction script so that when we expand upon our spline in the editor, we want it to update all the time as we do something. Otherwise, it would only be like we would do the spline pathing in the beginning, and then if we had it in the begin play to actually do the logic, then it would only be as soon as we clicked play the splines would appear. But this will be easier for us in the sense that we can get immediate feedback. So what we want to do first is we want to loop on our spline. So if we get our spline here, we can get or do a for loop, right click and type for loop. And we want to have an actual for loop, not a for each loop. That way we can assign indexes. And now a spline will consist of a certain amount of points in it. So if we were to get the num of spline points, like so, it would return how many spline points we have, which in the instance of like at the start we would have 2 spline points, right? But since we're working with a loop which normally works with something like arrays, the first index will always be 0, and since we have 2 spline points, we want to go from 0 to 1, which means 2 points. So we need to subtract 1 from this. And this is super simple stuff. It's normal programming stuff when it comes to arrays and such. So this is what we will be going through. We will be saying go through all of our different spline points and then do something with them. So the first part we want to do here is we want to take the index here and we want to promote it to a local variable. We can name this local current index, like so. So this will be the index that we're currently working on. And then in addition to that, we want to check our next index if we have one. So we want to we'll make a new variable and we'll call it local next index. We'll make this one an integer as well. And we'll set it to be whatever this index is plus 1. And the reason for this will become clear in a little while. Because what we're going to be doing with this is we're going to be adding a spline mesh component. And we'll be doing that dynamically. So if we right click and do add spline mesh component, like so, then we can assign here a static mesh for it to use. And it's super simple for this purpose if we're going to make a pipe that we use a cylinder. So if you type in cylinder, you get a shape cylinder. And to show you how a cylinder looks in the world, if we go in here and search for cylinder like so, you can see that is what it looks like. And this piece of geometry has quite a lot of faces and vertices on it. It's easy to see if you change from lit mode to something like brush wireframe. You can see it has a bunch of faces for it to use, and that is important when it comes to splines, because what will happen when you create a spline is something sort of like this. If we move this up a little bit further, and we'll make a little bit of a gap. So a spline point will be something like at the beginning of this cylinder and at the end of this cylinder. And this end point over here will also act as the start point of the next cylinder. And then if you had a third point, that would be up here. Now, if you were to change the rotation or translation, so it would be something like on the side like this, a pipe wouldn't look very good if it was just like this, keeping the rotations. So what it will be doing is it will take, first of all, its position, making sure that it's aligned like so. But also if it's offset to a side, then it needs to somehow stretch its geometry to make sure that this edge over here aligns with this edge and this edge over here aligns with this edge. And it does that by using what we talked about earlier with the tangents. So if you click on one of these points that we had in our earlier blueprint, you can see that it has tangents here, which shows a tangent is basically a line that is drawn along a curve, just a straight line, and then it touches the point on a curve here, and that is where the tangent is. And that allows us to be used here so that it can figure out how it needs to stretch the geometry here so that they align properly with each other. And that is why we need to have a certain amount of detail in the actual geometry that we're using, so that it allows it to morph it to our needs. This will become much more clear in a little bit here. We'll just continue for now. But what we've done here was we added the shape cylinder here, so that part is done. Other than that, we need to make sure that this mesh component knows which direction it is going. And you can do that by using a set forward, right? Forward axis. So meaning which way is forward for this one. And this is going to be dependent on your geometry. So in our case, we would like a piece of pipe to go along this axis, right? From the bottom to the top here. That means we follow the blue line. The blue line here is, as you know, the z-axis. And that means that we want to use our forward axis as z there. And that's all we need to do when it comes to that. Other than that, now we come to the actual part of meshing these together. And it is done by using, let's go down here and do a reroute node. like so. Then we'll drag from this and we'll do a set start and end. So this uses a spline mesh component to determine how the first and the second, the start or the end. So the beginning and the end of the geometry is going to adhere. So it's going to need a position and it's going to need the tangent to know which way to direct itself. And this is really easy to get. All we have to do is get our spline. You can do it from up here or down there, just like before. So get our spline. And from this we get location and tangent at spline point. Now we need to have 2 points, a start point and an end point. And that is why we made these indexes earlier. So we have a current index, and then we make a duplicate of this and use that one and the next index. So now we have the location and tangent for the current index that we have in our loop over here, and also for the following index because we saved them over here. So we get both of these and we just plug them in here. So the start position and the start tangent, the end position and the end tangent, and that's all. And we're done. That's the... oh, that was not what I intended to do. I wanted to say. It doesn't get more complex than this for this simple example. So if we go into our world now and we bring out our pipe, you can see that it appears like so. And now we can just press a spline point and then use Alt and drag it along a direction, and you see that it will elongate the spline. And you can move it and you can see that it will actually deform in the parts here where 2 points are meeting. So that's all you need to do to make something like this work. And this doesn't need to be applied to only tubing and what's called pipes. It can be used in a lot of creative ways. It can be used for this mesh could instead be a road, so the road is transforming like this, and it is actually something that is quite readily available when you're doing landscapes as well, to create splines like this in landscape mode as well. And you can use it for ropes and anything that you want to make some sort of dynamic shape of like this that uses a sort of uniform mesh. But again, this is just the beginner level of this. This is something you can build extremely much upon. You can have each of these segments, for example, being individually different from each other. They could have like consist of multiple meshes, and you can make like an array of meshes that you write out or create out, and it will have deformities on different parts, and it could have so there could be like pipes that are broken and have holes in them in certain parts, or they would have things like smudges and stains on them and such. There is a lot of depth here if you want to build upon it. But this is the very basic general concept of how splines work and how they can be used for some simple examples. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions you may have or comments down below. Subscribe and share this video if you want to see more like it in the future. In the next video we will be looking at some flow control or flow logic to make sure that you have some basic tools of structuring your blueprints. That is all for now. Keep on learning. Take care.